NFPA 59A, the standard for the production, storage, and handling of liquefied natural gas, outlines safety requirements for LNG handling and storage. NEC 500, hazardous classified locations, specifies electrical installation requirements in areas with flammable gases or vapors. NFPA 59A mandates that electrical systems in LNG facilities must adhere to NEC 500. This means complying with both standards when installing electrical equipment in an LNG facility. NFPA 59A provides requirements specific to LNG facilities, while NEC 500 provides general requirements for hazardous locations. NFPA 59A does not detail specific electrical competence for those working in hazardous locations. However, it stipulates that only qualified persons can perform electrical work within its scope. The NEC defines a qualified person as someone with the skills and knowledge related to electrical equipment construction and operation, and who has received safety training to identify and avoid associated hazard. Therefore, to comply with NFPA 59A, personnel in hazardous locations must have adequate electrical competence and safety training, achieved through education, experience, and training programs. For LNG facilities, manufacture the plant in accordance with NFPA 59A. This standard is specific to LNG safety and storage, containing requirements not found in NEC 500. If the plant is not an LNG facility but is in a hazardous location, manufacture it according to NEC 500. NEC 500 provides general electrical installation requirements for hazardous locations, regardless of the hazard type. In essence, the connection between NFPA 59 and NEC 500 lies in the fact that NFPA 59A, which focuses on liquefied natural gas facilities, references and requires compliance with NEC 500 for electrical installations within those hazardous locations. NEC 500 provides the fundamental guidelines for electrical safety in areas where flammable gases, vapors, or dust may be present. NFPA 59 builds upon these guidelines, adding specific requirements tailored to the unique hazards associated with LNG. This means that if you are designing, installing, or maintaining electrical systems in an LNG facility, you must consult and adhere to both NFPA 59 and NEC 500. The electrical competence required under NFPA 59 is not explicitly detailed within the standard itself. However, it is implicitly understood that personnel working on electrical systems in LNG facilities, particularly in hazardous locations, must possess the necessary skills, knowledge, and training to perform their tasks safely and effectively. This competence typically includes a thorough understanding of electrical principles, wiring methods, safety procedures, and the specific requirements of NEC 500 as they apply to hazardous locations. Furthermore, personnel should be familiar with the specific hazards associated with LNG, such as the risk of flammable gas releases and explosions, and the precautions necessary to mitigate these risks. The selection of a manufacturing standard depends on the type of facility being built. If the facility is specifically designed for the production, storage, and handling of liquefied natural gas, then NFPA 59 should be the primary standard used for manufacturing and construction. NFPA 59 provides comprehensive requirements for all aspects of LNG facilities, including site selection, design, construction, equipment, and operations. It addresses a wide range of safety considerations such as fire protection, spill prevention, and emergency shutdown systems. On the other hand, if the facility is not an LNG facility but is located in a hazardous location due to the presence of other flammable materials or processes, then NEC 500 should be the primary standard used for electrical installations. NEC 500 provides detailed requirements for the selection, installation, and maintenance of electrical equipment in hazardous locations, including considerations for explosion-proof enclosures, intrinsically safe circuits, and other protective measures. In some cases, a facility may be subject to both NFPA 59 and NEC 500. For example, an LNG import terminal may have areas that are classified as hazardous locations under NEC 500 due to the presence of LNG vapors. In these cases, the facility must comply with both standards, applying the more stringent requirements where there is overlap. It is also important to note that other codes and standards may apply to LNG facilities and hazardous locations depending on the specific circumstances. These may include local building codes, fire codes, and environmental regulations. Therefore, it is essential to consult with qualified professionals and regulatory authorities to ensure that all applicable requirements are met. The NEC, or National Electrical Code, defines hazardous locations based on the properties of the flammable materials present and the likelihood of those materials being present in ignitable concentrations. These locations are classified into different classes, divisions, and zones, each with specific requirements for electrical equipment and wiring. Class I locations are those where flammable gases or vapors are or may be present in the air in quantities sufficient to produce explosive or ignitable mixtures. Class Roman II locations are those where combustible dust are or may be present in the air in quantities sufficient to produce explosive or ignitable mixtures. Class Roman III locations are those where ignitable fibers or materials are not likely to be in suspension in the air but are easily ignitable. Within each class, there are divisions and zones that further define the degree of hazard. Division 1 locations are those where the hazardous material is present under normal operating conditions, or where it is frequently present due to repair, maintenance, or leakage. Division 2 locations are those where the hazardous material is not normally present but may be present in the event of an accidental release or equipment failure. Zones are used as an alternative to divisions for Class I locations. Zone 0 locations are those where the hazardous material is present continuously or for long periods. Zone 1 locations are those where the hazardous material is likely to be present under normal operating conditions. Zone 2 locations are those where the hazardous material is not likely to be present under normal operating conditions but may be present for a short period. The NEC provides detailed requirements for electrical equipment and wiring in each type of hazardous location. These requirements are designed to prevent explosions and fires by ensuring that electrical equipment does not create a source of ignition. Some of the key requirements include the use of explosion-proof enclosures, intrinsically safe circuits, and purged and pressurized systems. Explosion-proof enclosures are designed to contain an internal explosion and prevent it from propagating to the surrounding atmosphere. Intrinsically safe circuits are designed to limit the amount of energy available so that it is not sufficient to ignite a flammable mixture. Purged and pressurized systems use a positive pressure of clean air or inert gas to prevent the entry of flammable materials into electrical enclosures. In addition to the NEC, other codes and standards may also apply to electrical installations in hazardous locations. These may include NFPA 59A, Standard for Purged and Pressurized Enclosures for Electrical Equipment, and ISA 12.12.1, Non-Incentive Electrical Equipment for Use in Class I and Roman II, Division 2 and Class Roman III, Divisions 1 and 2 Hazardous Classified Locations. These standards provide additional guidance on the selection, installation, and maintenance of electrical equipment in hazardous locations. The competence of personnel working in hazardous locations is critical to ensuring the safety of the facility. These personnel must have a thorough understanding of the hazards involved, the applicable codes and standards, and the proper procedures for installing, maintaining, and operating electrical equipment. They should also be trained to recognize and respond to potential hazards, such as leaks, spills, and equipment malfunctions. In addition to formal training, personnel should also receive on-the-job training and mentoring from experienced professionals. This will help them to develop the skills and knowledge necessary to perform their job safely and effectively. Regular audits and inspections should be conducted to ensure that electrical installations are in compliance with applicable codes and standards and that personnel are following proper procedures. Any deficiencies should be corrected promptly to prevent accidents and injuries. The specific requirements for electrical installations in hazardous locations can be complex and may vary depending on the type of facility, the type of hazard, and the applicable codes and standards. It is essential to consult with qualified professionals to ensure that all requirements are met and that the facility is designed, installed, and operated safely. The NEC is updated every 3 years, so it is important to stay current with the latest requirements. The NEC is adopted by most states and local jurisdictions, so it is the primary code used for electrical installations in the United States. However, some jurisdictions may have additional requirements or amendments to the NEC. It is important to check with the local authorities to determine the specific requirements in your area. The NFPA 59. A standard is also updated periodically, so it is important to stay current with the latest requirements. The NFPA 59. A standard is developed by a committee of experts in the field of LNG safety. The NEC is developed by a committee of experts in the field of electrical safety. Both committees include representatives from industry, government, and academia. The NEC and NFPA 59. Standards are both consensus standards, meaning that they are developed through a process of open discussion and debate. This helps to ensure that the standards are technically sound and reflect the best practices in the industry. The use of qualified professionals is essential for electrical installations in hazardous locations. These professionals should have the necessary education, training, and experience to design, install, and maintain electrical systems in accordance with applicable codes and standards. They should also be familiar with the specific hazards involved and the proper procedures for mitigating those hazards. The use of qualified professionals can help to ensure the safety of the facility and prevent accidents and injuries. The NEC contains specific articles related to hazardous locations. Article 500 provides the general requirements for hazardous locations. Articles 501 through 506 provide specific requirements for different types of hazardous locations. These articles cover topics such as wiring methods, equipment selection, and grounding and bonding. The NEC also contains articles related to specific types of equipment used in hazardous locations, such as motors, transformers, and lighting fixtures. These articles provide additional requirements for the design, installation, and maintenance of this equipment. The NEC also includes tables and figures that provide guidance on the selection of equipment and wiring methods for hazardous locations. These tables and figures can be helpful in ensuring that electrical installations are in compliance with applicable codes and standards. The NEC also includes examples of how to apply the requirements of the code to specific situations. These examples can be helpful in understanding the intent of the code and in ensuring that electrical installations are designed and installed correctly. The NEC is a comprehensive code that covers a wide range of topics related to electrical safety. It is essential to consult the NEC and other applicable codes and standards when designing, installing, and maintaining electrical systems in hazardous locations. The use of qualified professionals is also essential to ensure the safety of the facility and prevent accidents and injuries. The information provided in this narration is for general guidance only and should not be considered a substitute for professional advice. Always consult with qualified professionals and regulatory authorities to ensure that all applicable requirements are met. Electrical installations in hazardous locations require specialized knowledge and expertise. It is important to work with experienced professionals who are familiar with the applicable codes and standards and who have a proven track record of safety. Proper design, installation, and maintenance of electrical systems are essential for preventing explosions and fires in hazardous locations. Attention to detail and a commitment to safety are critical for protecting workers and the environment. The NEC and NFPA 59. Standards are constantly evolving to reflect new technologies and best practices. It is important to stay current with the latest requirements to ensure that electrical installations are safe and compliant. Continuous learning and professional development are essential for personnel working in hazardous locations. This includes attending training courses, reading industry publications, and participating in professional organizations. A strong safety culture is essential for preventing accidents and injuries in hazardous locations. This includes promoting open communication, encouraging employees to report potential hazards, and providing adequate resources for safety training and equipment. Electrical competence in the context of NFPA 59 and NEC 500 extends beyond simply understanding electrical theory. It involves a practical understanding of how electrical equipment behaves in hazardous environments and the potential risks associated with its operation. This includes the ability to identify potential ignition sources such as sparks, arcs, and hot surfaces, and to implement measures to prevent them from igniting flammable materials. Competent personnel should also be able to properly select, install, and maintain electrical equipment that is specifically designed for use in hazardous locations. This equipment is typically more expensive and requires more specialized knowledge than standard electrical equipment. However, it is essential for ensuring the safety of the facility. In addition to technical competence, personnel working in hazardous locations must also possess strong safety awareness and a commitment to following safety procedures. This includes wearing appropriate personal protective equipment, such as flame-resistant clothing and safety glasses, and following lockout/tagout procedures when working on electrical equipment. It also includes being aware of the potential hazards in the work area and taking steps to mitigate those hazards. Effective communication is also essential in hazardous locations. Personnel should be able to communicate clearly and concisely with each other about potential hazards and safety procedures. They should also be able to report any unsafe conditions or incidents to their supervisors promptly. A strong safety culture is built on trust and respect. Employees should feel comfortable reporting potential hazards without fear of reprisal. Supervisors should be responsive to employee concerns and take action to address any safety issues promptly. The design and construction of LNG facilities require a multidisciplinary approach. Electrical engineers must work closely with mechanical engineers, chemical engineers, and other professionals to ensure that the facility is designed and operated safely. This includes coordinating the design of electrical systems with the design of other systems such as fire protection systems, ventilation systems, and emergency shutdown systems. It also includes ensuring that all systems are properly integrated and tested before the facility is put into operation. The commissioning process is a critical step in ensuring the safety of an LNG facility. During commissioning, all systems are thoroughly tested to verify that they are functioning properly and that they meet all applicable codes and standards. This includes testing the electrical systems, the fire protection systems, the ventilation systems, and the emergency shutdown systems. Any deficiencies that are identified during commissioning must be corrected before the facility is put into operation. Regular inspections and maintenance are essential for maintaining the safety of an LNG facility. Electrical systems should be inspected regularly to identify any potential problems such as loose connections, damaged wiring, or corroded equipment. Maintenance should be performed on a regular basis to prevent equipment failures and to ensure that all systems are functioning properly. A comprehensive maintenance program should include both preventive maintenance and predictive maintenance. Preventive maintenance involves performing routine maintenance tasks such as lubricating equipment and replacing filters on a regular schedule. Predictive maintenance involves using sensors and other technologies to monitor the condition of equipment and to identify potential problems before they occur. The goal of predictive maintenance is to prevent equipment failures and to extend the life of equipment. Emergency preparedness is also essential for LNG facilities. A comprehensive emergency response plan should be in place to address potential emergencies such as fires, explosions, and spills. The plan should include procedures for evacuating personnel, controlling the release of hazardous materials, and contacting emergency responders. Regular drills and exercises should be conducted to ensure that personnel are familiar with the emergency response plan. The goal of emergency preparedness is to minimize the impact of any potential emergency and to protect the safety of personnel and the environment. The regulations governing LNG facilities are constantly evolving. It is important to stay up to date on the latest regulations and to ensure that the facility is in compliance with all applicable requirements. This includes monitoring changes to the NEC, NFPA 59A, and other relevant codes and standards. It also includes staying informed about new technologies and best practices in the LNG industry. A commitment to continuous improvement is essential for ensuring the long-term safety and reliability of LNG facilities. This includes regularly reviewing safety procedures, conducting audits and inspections, and implementing corrective actions to address any identified deficiencies. It also includes encouraging employees to participate in safety training and to provide feedback on how to improve safety. The goal of continuous improvement is to create a culture of safety that is ingrained in every aspect of the facility's operations. In summary, manufacturing plants in hazardous locations, especially LNG facilities, demands a meticulous adherence to both NFPA 59 and NEC 500. NFPA 59 offers specific guidelines for LNG facilities, while NEC 500 lays the groundwork for safe electrical installations in hazardous environments. Competent personnel, characterized by thorough training and practical experience, are paramount to ensuring safety and compliance. Continuous learning, stringent maintenance, and proactive emergency preparedness further contribute to mitigating risks and fostering a culture of safety within these critical facilities. The interplay between NFPA 59 and NEC 500, coupled with a steadfast commitment to safety, forms the cornerstone of safe and reliable operations in hazardous locations.